My name is Gloria Warland. I'm with Viavi Solutions, and we welcome you to our Uplink interference webinar today. This is our best practice series, and this is the first of the series of 3 covering PIM detection. Before I introduce our speakers, I want to let you know this session is being recorded. All guests are muted, and we are monitoring question and answers. To submit a question, scroll to the bottom of your screen. You'll see a Q&A box. You can type your question in, and we will respond either in the question and answer box or bring the question to our speakers for the answer that's appropriate for you. This session will last about 30 to 40 minutes. And without further ado, I'll introduce my speakers now. Eduardo Nzunza, who is with our product line management team, and Dan Smeja, who is a domain solutions expert, and they're going to provide you this educational information today. I'm going to turn it over to them now. Thank you.
Thank you, Gloria. Hello, everyone, and thank you for being here and participating in this webinar. In this session, let me just say that it's going to be a little bit more technical than commercial. But as Gloria said, if you have any questions, please feel free to send them over, and we're going to be able to answer them the best we can. So with that, let me just go briefly into the different topics that we're going to be covering. Even though PIM or passive intermodulation is a well-known topic, I'm just going to cover the basics of what it is and why it's a problem in the uplink for mobility users. And also try to answer the question of, is this a problem on TDD carriers? Typically, this PIM problem has been an issue for FDD carriers, but I'm just going to cover briefly why it might also be a problem in TDD. And then at what power level PIM can be affecting service. And I'm going to try to answer the question of that, as well as how PIM and detection works with RFoCPRI. How is data of the RF signal being mapped or transmitted over the CPRI protocol? And we're going to do a brief demonstration on RFoCPRI with a radio. And actually, we have on that radio a PIM issue. And then a couple of examples that we have seen in the field on basically this comes with all the flexibility on mapping RF data on CPRI. And even when we have multiple carriers, what's going to be the best way to identify the carrier that we're testing? And some of the best practices in terms of PIM detection and mitigation process. And at the end, I'm just going to give you kind of a quick reference of additional information. Okay, with that, let me just briefly go into the basics. Passive intermodulation, what it is. So basically, it happens when 2 signals in 2 different frequencies go through a transmission path, and that has some conductivity problems or conductivity characteristics. And so, for example, here on the right-hand side, I'm showing a radio. I'm just making the example here that that radio is actually a couple of transmitters, and we have 2 different frequencies with a certain power level, and that goes through the antenna. That it's a load, but it's an antenna, 50 ohms, and then through that it goes through multiple elements, jumpers and combiners perhaps, and those are typically prone to generate PIM. And the effect is that with that, those PIM products that are basically a combination of my 2 fundamentals, then we're going to have intermodulation distortion of different levels. The third being the most powerful one, then followed by 5th, 7th, and so on. But basically, this is the basics of why this happens. Now, how this is reflected in orthogonal frequencies and by orthogonal or OFDMA, I mean signals that are constructed by multiple carriers, which happens to be the structure of LTE and 5G. So for example, here on the slide, I'm showing my LTE signal, 10 megahertz, and as you can see, it has 600 subcarriers. And certainly those are basically work to construct my LTE channel. But if I have a PIM problem, then that is basically gonna create a multiple combinations of my different intermodulation that might affect my uplink. And when we have a presence of PIM, is going to be a specific signature that we're going to see, and we're going to be showing some examples. But in essence, it's going to be rising the noise floor of the uplink. And as you can see here on the on this example, based upon the location of my downlink, is how that is going to be reflected on the uplink. So in this example, I'm showing that, yeah, this can actually go through all the way into my uplink, which happens to be at 782. And this is just a calculation of my subcarrier 600 with subcarrier 0, that specific combination. And that happens to be intermod 7, where it's landing on my uplink. So that is a problem now. We have a problem in TDD radios. For example, we have 5G mid-band now, and this happens to be in the 3.7, 3.8 band. And the answer is yes. Well, first off, if we have TDD has downlink and uplink in different time slots. So if we have a PIM problem on a different frequency, who cares? Well, from that standpoint, maybe yes, maybe not. I'm saying that because who cares is not going to affect that specific channel, but might affect an adjacent channel. And that might be owned by one operator, might be owned by a different operator, but it might be a problem. Now, this has been somewhat eliminated by the fact that different mobile operators, I believe, have come into agreement that they will be transmitting the same frame configuration. What that really means is that on the same time, they're going to be transmitting downlink, and at the same time, they're going to be transmitting the uplink. So in essence, even though we might have PIM between the mid-band carriers, it is not going to be interfering with the uplink, unless any of those carriers have a timing problem. And if so, then the downlink is going to be landing in the uplink, and certainly is going to have interference problems. And that happens to be one of the topics that we're going to be talking about on the next series. Now, different aspect is, okay, so typically that those 5G carriers or 5G radios typically are not installed on a just standalone site. That site is being collocated, meaning that on existing macro cells, the 5G radios are being deployed. And what that happens is that if we have a mid-band radio, as you can see here, we're also collocated with other radios, which the combination of those happen to affect my 5G carrier if we have PIM on the transmission line of the other radios. And that is so because these other radios happens to be in low band, and low band is basically FDD carriers. So all the downlink is being transmitted all the time in one specific frequency because the uplink is in a different frequency. Therefore, if I have a PIM problem on the low band, it's going to affect the entire time, and that those products are going to land in my C-band. This is an example that we got from one of our partners, ConcealFab, and as you can see, the different combinations of intermod products that might be landing on C-band. So important to check and verify that on those all those sites, the low band carriers are not being transmitting any PIM products. Okay, now how big of a problem is passive intermodulation? Well, that happens to be related to the sensitivity of the radio. So here in this table, I'll just grab the different sensitivity levels defined by 3GPP. in different technology segments. So we have from back in the day, GSM, LTE, and 5G. And as you can see here in 5G, they have defined different configurations of radios. First off, different types, from a wide area network or a macro cell that doesn't have any limit in terms of transmission. We also have the medium range, that those radios transmit up to 38 dBm, and the local area radios, which are 24 dBm. Now, as you can see in each one of them, we might have different carrier bandwidths from 5 to 100 based upon the radio type. But as you can see here, there are different sensitivity levels, and that is basically the important level for which, if we have a PIM that is close to that sensitivity level, then it's going to be a problem. And why it's a problem? Because, again, sensitivity based on this standard says that we have to have up to 95% of throughput, and that has to be guaranteed with specific measurement or reference channel. In any case, if we have a PIM product, certainly that throughput is going to get affected. So let me just go back into my uplink and downlink, and then I have my two frequencies that are creating some PIM products. Then I have a specific power level that I'm transmitting those tones or those frequencies, those fundamentals. Let's say that we're transmitting at 46 dBm. Okay, now the relationship that we have between that and the PIM product, it's about the difference between them, it's about 136 dBc, or that's a difference between those two. Now, if we take a look from a dBm perspective, that means that that PIM level, it's a neg 90 dBm. So if we look back into our sensitivity level, we see that that is truly a problem for 5G radios. Right, okay, so how PIM is tested? So we have a couple of different methodologies. One is the conventional way, and that is we have a remote radio head with a PIM, and basically here we disconnect the radio and we connect an analyzer that is going to be transmitting a couple of tones. So if I transmit 2 tones, I expect to see one intermodulation product that is landing in the uplink. And then I keep one of those tones fixed, and then I change the frequency of my second tone, so then we can mimic a wideband signal to see how that is being affected into the uplink. Now, with this type of analyzer, or this type of approach, then I certainly need to have different analyzers per the frequency of this radio. So now the alternative is to have the same radio, but instead we're going to be having a monitoring port through the CPRI link. And with that CPRI information, then we're going to be able to extract all the RF components exactly the way that the radio is receiving the data. So here we're going to be able to show then the uplink of all the different branches. And by branches, I mean the different antennas. So, for example, in LTE, we have heard that it's been transmitted and transmit, receive, multiple input, multiple output. That means that we have multiple antenna elements that are transmitting and receiving. Therefore, in this case, for example, we might have 4 different antennas, or MIMO 4, but that can be different configurations. One configuration might be that it's SISO, basically just one antenna transmitting and one antenna receiving, or MIMO with multiple antennas. In this example that I'm showing right here, as you can see, we have a slope. So we're looking into the uplink, but there's a slope, and that slope is a PIM signature. And again, just as a reminder, this happens because of the the PIM that is induced by my downlink. And in this specific case, the downlink happens to be in a lower frequency of my uplink. Therefore, we have that slope. And as you can see, actually, in this case, we have PIM in all the branches. So we have here 4 different traces that each one of them corresponds to one antenna. And as you can see, all of them are being affected. Okay, so a quick comparison in terms of these 2 methodologies. RFoCPRI is certainly more convenient because it's faster. We just tap into the CPRI link. We lock the radio for a couple of minutes just to have that monitoring port, and the radio can still be transmitting normally. And we have one specific solution for multiple frequencies, so it's not frequency dependent. And certainly we can do some mitigation of that PIM if it's internal. We can just tap into the cables and jumpers and fix it while we're looking into the PIM signature at the same time. So remotely we can have our PIM measurement. And if we have PIM, we go through the process of mitigating that PIM if it's either internal or if it is external. And if it's external, we have a process with which we use a PIM probe to go and find any or multiple sources of PIM, and then we just go through the process of covering them or trying to fix them to pinpoint exactly at which point is a PIM source or a PIM problem. I'm going to elaborate a little bit more later in this presentation. Okay, so what is the CPRI aspect of it? So first, we have the protocol. So we have on the protocol the connectivity between the remote radio head and the baseband unit, and that can have different link rates. So first off is the CPRI layer 2 verification. That basically is going to take care of, okay, that link, it's at the proper line rate. And we have a good amount of power, optical power coming in. For example, we know that these SFPs, the small form factor pluggables, those have also a certain level of sensitivity on the light. So we have to check that that power level is above, say, neg 15, around neg 15, neg 17 dBm, because typically those are transmitting at about 0 dBm, but the sensitivity is about neg 20. And if we have an optical tap, which basically brings down the signal 3 dB because we have a 50-50 split, we just need to check that that fiber has proper characteristics. And by that I mean, because I know that some of these fibers go through different segments, distribution panels, and so on. And even sometimes in those interconnections, there might be some dirt that attenuates the signal. So anyway, it's always good to have an assessment of the optical power, because otherwise the radio might be frequently kind of shutting down or showing some odd behavior, and that happens to be because of just the physical layer in optics. Now, once this super layer 2 verification, everything is green, everything looks good, then we go to the analysis or demapping of the RF data, for which then we can identify the uplink carriers of all my different branches. In this example that I'm showing, as you can see, we have 4 branches, 4 uplink signals, and all of them are clean. As you can see, the uplink noise level is flat. We don't have any slope on any indication that we have a PIM. And then on the right-hand side, I have the same one, but we did just a zoom in on one specific branch. And as you can see, we don't have PIM. Now, that being said, as you can see on this last screen that I'm showing there, that is being done with a spectrogram. And that is helpful because with the spectrogram, and as you can imagine, is this testing, as I mentioned before, we're looking all the time into the uplink. Therefore, if there's a problem, and by a problem can be either PIM or also can be an external interferer. And if we have external interference, then we're going to be able to look and analyze the profile or the characteristic of that external interference. And we can see that sometimes that interferer might be just in a specific frequency and is static and stays on that frequency. Sometimes that interferer is hopping, or sometimes that is a broadband interferer based on the source of that interference. And this is going to be a very good methodology to assess and identify the behavior of that interference. And that is very useful because with that behavior, then we can assess, okay, this is the how that interference behaves. And we're going to be using that to do an interference finding, which that happens to be also one of the topics that we're going to be talking about on this series. Okay, so bear with me. We're going to be talking about external interference, how to characterize it, and how to find it in the upcoming webinar in this series. Okay, very good. So now here we have the RFoCPRI PIM analysis. And as you can see here, we're making a comparison between two branches. On the left-hand side, we have one that happens to be antenna 1, and the right-hand side, we have antenna 3. Clearly, we see a difference in the noise level of the uplink, and here on the right-hand side, actually, we're overlapping all the different branches, all the antennas. So effectively, in a single spectrum, we're seeing all of them. And as you can see, one of those signals, which happens to be my receive 3, or actually it's my antenna 4, that is showing a PIM problem. Now, just due to the fact that it's only showing in one and not on the others, we probably can come into a conclusion that this is internal PIM, not external, because if it will be external, typically that will be reflected in multiple antennas. But again, this is a typical PIM signature, and in this specific case for this carrier, the downlink happens to be in a higher frequency than the uplink. Right, so now let me just go briefly on how PIM works. I'm not going to spend a lot of time here, but if you have any questions, please let us know. So we have an analog signal that is going into my RF path. And this analog signal, we need to digitize it by doing some sampling. We take some sample bits. We can also pad that stream with some stuffing bits. And the CPRI protocol gives us multiple options, a number of the bits that can be used between the downlink and the uplink and the stuffing bits. And then when we have that sampling, we basically group them. We group those bits in antenna carriers, and these antenna carrier values can also be, it has different values from 4 to 24, and that is based upon the bandwidth of the carrier that we're transmitting. The unit that, or the bandwidth, let's say, for antenna carrier is based on UMTS. So that's about 3.8 megahertz. So we have a bandwidth that it's, say, 10 or 20, then we have bigger groups that we need to accommodate that the battery of that carrier. So we group them, all of them, and also we have some reserve beats. Those reserve beats is just a way to float or to put a path between different antenna carrier groups. And then at the end, we just put it in a frame and send that frame out. So this is how it's digitized and basically is transmitted my RF data into my CPRI protocol. And as you can see here, there are different variants, different variations that can be used. Now, the good thing is that we have been able to put all those variants in an easy way that we can identify and make changes. So effectively, we can analyze any type of signal. In this example that I'm showing here, we have my mapping. So let me see if actually I can show my cursor here. So this is the entire signal, my CPRI bandwidth. All the overhead is here on the left-hand side in a purple color. But here, as you can see, when we look into the signal, all the RF data is here on in gray. So we know how these data is in the CPRI word. Now, we've seen different configurations, and that's totally valid and acceptable, where these data can be at the beginning of the word, somewhere in between, or in the middle of the word, or at the end. In this specific example, we have it right at the end. Right. And here we have a section. This is all the RF mapping, and here we have a section where we can make all different changes in terms of the configuration. And with that, let me just switch back to Dan, and Dan is going to give us a quick example on how this looks in a real radio.
Absolutely. Let me just share my screen. I cannot share. You must unshare first, Eduardo, apparently.
Yeah, sorry.
That's fine. This is all fun stuff. Screen one. And share. All right. Let me know when you can see this. Hopefully there's not a lot of stuff popping up on your screen and I have it running.
Yeah, we can.
Okay. So everyone, my name is Dan. Thanks for the people texting me in the background. I got some friendlies on the line. So no heckling, please. Unless it's a real heckle, that's fine. So what Eduardo was showing you was obviously the presentation. I happen to have a real radio that I'm tapped into. You can see that in the bottom right corner, but just a quick explanation of how we do our visual representation, right? Representation of the signal. Colored bars, as he said, are our branches that we say, look, this is the signal. When you run the unit, it taps in there. I personally just put in my 20 megahertz. We could have hit the config button, but it defaults to the gray area and it lines up the signal. So we have it here. So that's good for the setup. And I'm on a single carrier system. We could be on a multi-carrier system. I'm not showing that because I don't have access to that today. And just for clarity, this is a 4x4 MIMO. But as he said, we can do single 4x4 and even up to 8x8 if we really wanted to. My setup does not allow for that. So a quick look, and just to express, this is an actual live signal we're looking at with some RF coming in. I've offset some of the frequencies with some cooperation, so we're not going to pick up a lot of user traffic on purpose because that's not fair when I start turning on PIM stuff. I'm trying to be nice to all the players out there. Fairly quickly, system is able to analyze a single antenna. If we're isolating one branch, if I want to isolate two branches out, I can come here, pick my branches, but more importantly, isolate all four branches. So this is our 4x4 MIMO system. You can see we have 4 branches. I do not have any PIM sources in right now, so it looks nice and clean. But let's talk about what we tend to do in the real world when we're working with our customers is we go right to this button right here. And I'm going to turn off all the metrics for a second. And we do what we call the 4x4 overlay. And the reason we do this is we want our customers to be able to quickly isolate one thing from the others. As Eduardo explained, if it's an internal problem, if it's a single port problem versus a multi-port problem or branch, we should say, you can quickly isolate it here without having to stare at the y-axis, without having to look at anything. And I call it the Sesame Street method. And that's not a slam to anyone, but it's the old adage of one of these things looks different than the other. So let me create some PIM. And you can see pretty darn quick, and I may have to go run out there and move an antenna. There it goes. Pretty darn quick. One of these things is not like the other. I may have to turn the power down on this one. It's fairly simplistic. I have in a PIM problem. I want to isolate it with numbers. Maybe I'm sending this to a report up to a manager. We actually will isolate the whole thing down with min values, max values of power per branch, give you a bar chart. Hey, again, one of these does not look like the other. I can pick what I want to look at. And I can drop it back down to 0, which I did. So I have to turn it on and off sporadically. Again, I'm trying to protect the locals, if you will. Extremely simplistic system, defined on what Eduardo talked about. We tapped into the fiber. We are looking at the system live, and I've had a couple questions in the background that I've been trying to answer. So thank you for the questions. We're using the antennas that are in the system. So the design of this is you've got your RRU or your RRH. There are some questions about LTE versus 5G. If it's CPRI based 5G, this works just as well on 5G as 4G. We'll get into some of the questions as we get to the end of the call, but this allows us to see exactly what the system is showing us. For those that are looking closely, I've got a couple narrowband spikes that are popping up in this. That's because, again, this is kind of in a building and it's bouncing around and there's just a lot of stuff going on. But from a PIM point of view, we've created this to be a real-time view, the ability to put a level to say, all right, in a perfect world, here's my starting point. As I start to create interference, you would actually take this and start to move it and go, okay, here's where my PIM is. Let's assume it stopped there. And now I'm going to run my PIM mitigation techniques. And Eduardo will go over that in some of the presentation. But a lot of the stuff that those of us who've done the normal PIM and the 2-port PIM testing or 2-tone PIM testing, it's very similar, right? There are PIM probes. We have them. They are out there. There's a lot of Conceal Fab and other people's PIM mitigation products that are temporarily used. And the nice thing about this system is when you see what you see on the screen, it's a real-time analyzer. We are seeing what the system sees, right? We are being affected by the system. In fact, I had to put some averaging on just to turn it down because we're getting on average about 20 to 30 sweeps per second in the system. So it changes rapidly. So I actually like to smooth it out so I can see the changes and not have to sit there and watch it jump up and down too much. And we can set reference points. For those who are used to spectrum analysis tools, we can set max holds and min holds. We can do all of the stuff we're used to from a spectrum analyzer, but we designed the tool to not have to use those because we know there's a lot of our customers who are not used to spectrum displays and they're used to traditional PIM methods, hence the button up here with all the data at the bottom versus the bar charts. I'm personally a graphical guy. That's why I like to look at the other screen and use a marker, right? Or not a marker, but a limit line. Fairly simplistic system. And with that, Eduardo, is there anything you'd like to add? Actually, let me turn that off. Or do we want to get back to yours?
Yeah, very good, Dan. Thank you. Appreciate it.
No problem. I will unshare and I'll get in the background and start answering the questions.
Awesome.
Yeah, there are about 5 questions, so we'll look forward to those now. And one fellow had his hand raised. I don't know if that was for something related to what you were showing on the screen or to make sure his questions got answered. So
at this point, if you type it in, whoever raised your hand, I'll answer it and we can go back to my screen at the end of the presentation. Absolutely.
Thank you.
Okay, very good. Thank you. So let's move on. So let me just share with you some of the examples here that we have seen in the field, because as you can imagine, with all these different variants in CPRI, it's a little bit of challenging. So for example, this is an interesting case. As you can see here, I'm showing that we have, in this case, we have multiple carriers. So we have actually 2 component carriers in 5 megahertz with MIMO 4X, and also 2 component carriers at 20 megahertz on MIMO 4X. So we're looking into the CPRI link here. As you can see, all the RF data is at the end. And we're just looking into the 5 megahertz, which happens to start here with my RF data. All these different colors that you see are basically those A antenna carriers that I briefly explained on how the CPRI is mapping the RF data in. So basically, we just put color coding in them. And that basically means that here we have a couple of antenna carriers. This is a group. This is for one antenna. So we have on green, we have antenna 1. In brown, we have antenna 2 or antenna 1 based on the numerology you're using. But in any case, the 4 antennas are here. And you can view them by the different color coding. Similarly, here on the right-hand side, we have on the other section, on the rest of the data, is my 20 megahertz carrier. Now, the difference here is that for 20 meg, we need to have, in this case, 5 different antenna carriers to create a group for that antenna. Okay, this is good. However, sometimes we've seen that some of these antennas are not necessarily of that component carrier. Let me just, in this case, for example, as I mentioned before, we have 2 component carriers at 2 different frequencies, both at 5 megahertz wide, but they're transmitting 2 different frequencies, let's say 1700 and 1900. Now, we tend to believe that all these subsequent antennas are for that component carrier. But this is not always the case. And this happens to be this example that I'm showing. So let me just give you an example on what's the best way to detect which antenna corresponds to that component carrier that we're analyzing, and why this is important. This is important because if we happen to identify there is a problem with one antenna at that specific frequency and happens not to be that one, then we're going to be trying to fix or troubleshoot an antenna that is probably good. Now, how do we know which antenna we're analyzing? And that's simply by generating a reference signal. So here with our instrument, the analyzer, the OneAdvisor 800, at the same time that we're analyzing the CPRI RF data, we can also generate a tone. So as you can see here on the down here on this slide, we have a tone that is actually being generated by the OneAdvisor. So here clearly we now can pinpoint exactly that, yeah, that uplink corresponds to this frequency. Similarly, here to the right, we have those tones being generated. And again, I'm using them just as a reference to very clearly identify the frequency of my uplink. So at the end, we basically see here that if this is antenna 0 of one of my 5 megahertz, this is my first component carrier, antenna 1, and then as it happens, on that same CPRI link, we have antenna 0 of my second component carrier. And then on the right-hand side, I'm showing on the other CPRI link that I have my antenna 2, antenna 3 for one component carrier, and antenna 2, antenna 3 for the second component carrier. And again, this is very useful once we have a reference signal that we can properly identify the frequency of my uplink. This is one of the best practices that we have seen very useful. Now, mitigation process. So this is just a quick flow chart of what happens when we have a PIM problem. So first, we do an analysis on RFoCPRI. If there's no PIM problem, then it's an external interference and we go into a different process. But if we have PIM, so first off, we put some absorbers and blankets, and that is going to help us to make a distinction between external versus internal PIM. So if we still have PIM when we put a blanket, then it's internal, and then we do a kind of a process of inspecting and tapping most of the times and checking the connectors to make sure that all of them have the proper torque, and that typically solves the problem. So this is kind of just a loop until that PIM problem goes away. And as I mentioned, we can do that constantly while we're looking into the RF over CPRI in real time. If it is external, then typically we use a PIM probe and analyze with a real-time spectrum if we have some noise increases on that uplink signal. This is being done with the PIM probe. And then once we find a source, we cover that area with a blanket or foil, because and then we continue the process. And we do that because typically there are multiple places or multiple sources of PIM. And then at the end, we just mitigate it and create a report. Right, okay, so let me just give you a couple of examples quickly. So first, again, at the beginning of the process, we run the RFoCPRI. You can see here we have that typical PIM signature. We have a slope, so PIM is detected. We know which antenna is exhibiting these problems. So first off, we put some absorbers. So again, we used concealed fab as an example to put absorbers, and it all depends on the behavior of that PIM that we can assess or determine if it's an internal or external. So if PIM goes away, then it's external. If it's still there, then it's internal. Very good. Now, let's take this example and say that is an external PIM. So here we have in a rooftop, happens to have different, this example, I'm just pointing into a metal structure that we have. Typically, those are prone to generate PIM products. So we just go with a PIM probe from concealed fab, have a filter in it, and then use our analyzer to detect any rise on my uplink frequency. And if it happens, then we say, okay, so here we have a problem. It's sending a lot of PIM products out, so we need to cover that or mitigate it. In this example, in this same rooftop, we just put PIM foil that basically is going to be covering those instances. And at the end, after this process happened, as you can see here on my RFoCPRI PIM, the PIM has been mitigated. I don't have any longer any PIM problem in my uplink. Right, with that, I want to thank you all. We're going to be going into the question and answers as soon as we can. Feel free to keep sending questions to Dan, myself, and Gloria if we don't have the time to answer them all, or if you have a question later on. Here I have a couple of references that we have available in our website with the OneAdvisor 100 wireless platform. We have different resources, application notes, including PIM related, and how-to videos. And then on the right-hand side is where you can find the solution for interference finding, which again, I'm going to be talking about it on the next series or the next webinar of this series. Okay.
So Eduardo,
yeah, probably a few minutes to answer some questions.
Yep, I didn't want to cut you off, but we have tons of great questions, right? And I'm trying to type, and I'm a horrible typer, so I'm typing as fast as I can. Some of these I'm going to answer live, just because there's a couple questions that are just a little too complicated to answer here. So if I could steal the screen share for a second. Sure. Thank you. Let's go back to this one. That one, that should be my unit. The first one is something I completely missed, is how do you save the data? I should have actually pushed the button. Let's say we have something going on. I'm going to, again, fire up a little bit of RF garbage in here. Let's say we want to take a picture. There's many ways. You can literally just hit that button for a screenshot. That is a PNG file. More importantly, you hit this button right here, which is the save icon, and you get your choice. You give it a name. I'm going to call it save for lack of better time. We can do a report, which is a PDF where you can add information in where, hey, here's who I am, here's where I am, here's the site ID, here's what I'm looking at. Of course, always setup files. Once you get your setup the way you like it, you save a setup file. You can actually dump data to a CSV, not really practical here. What's nice though, is you can even log it. You can actually press this button and record the data. So if you see something that's constantly changing, you can actually just record it like TiVo, and then at a later time come back, play it back, and then do a lot of what we're talking about. Obviously, we're not doing that here, but to the person who asked me about reporting, absolutely, I won't fill in the data, but now I have a PDF of the test and the data that's in that screen. So I just want to make sure we clear that up. I completely missed that. So I appreciate you for that one. Hardest question of the day is from Rami. Can you please explain how you can get the same spectrum carrier on 2 different power amplitudes? Okay. So if we go here, what we do is we separate the screen into just 4 quadrants, if you will. It's the same spectrum analyzer screen with our power values here on the left side. So we use a dBm access, and I set some leveling on so it would fit nicely in there to somewhat realistic numbers. And so in a real spec an, right, you're going to get 1 amplitude at a time because that's how a spectrum analyzer works. In an RFoCPRI analyzer, and I apologize about jumping around, but it makes sense. We actually separate each one of these colored bars into a spectrum analyzer display. So for example, the one in the bottom right corner is only this light blue, teal, I don't know what color that is. If I move over to the orange brown one, it would display. So what happens is in this display, imagine this would be the blue, this would be the brown, one of those was salmon color, and the other one was the other one. We just separate them logically because the fiber and the mapping of the RF data in the fiber, we can separate antennas. And then I just, again, we use the nice little button here, and I'll turn off all the garbage. We put all 4 on the same screen. But understand, Rami, this is not a spectrum analyzer with an antenna on it. I mean, it is the tool, but in this case, we are doing this through the fiber, which is the next question I'm going to try to answer of how we tap it. So that's why you see 4 amplitudes at the same time that are not a max holder or a min holder or any of that stuff. So hopefully you got that. No way I was going to be able to type that. So great question there. Aziz, you put the word conducted with a question mark. I don't understand because I was typing and not listening to Eduardo. So we may need to imagine that one or maybe a little more detail on that. Mike asked, with 2x2 single antenna sectors using the ONA as a way to tell if PIM is an issue of internal versus external. Good question. In most internal PIM, if in most, and this is all, there's always a caveat there, it is a single branch, single port, whether it's the coax, the 4.3 adapter, or the antenna itself. That's the problem. And I'll do that here with a 2x2 MIMO. Let me just separate these and show it here as a 2x2, right? In this case, I've got one that's perfectly flat and is exactly where I'd want to see it, and I've got one that's not. You could allude that this is a single port or a internal problem. It is not 100%, but you can allude to that because in the other side of that is when it's an external problem, it almost always affects at least 2 branches. And if you think about how branches are, right, you've got your antenna 1 and 3 are usually the same polarization, plus 45, for example, and 2 and 4 are going to be the negative 45. The 2 positives at a minimum should get affected. And I know there's people out there that are going to say no, and that's true because there's always a gray area here. But that's the easiest way to figure it out. And my dirty little secret in the background on my little setup is, again, I have an antenna. The reason I have single port PIM is I've loosened my N adapter, which goes from a DIN, because this is a really old setup, to a coupler to an N adapter. And I just unscrew it enough to where I'm getting a horrible VISWAR, if you will. And that's how you get single port PIM for me, is I have loads on it and I just unscrewed one of them, right? So hopefully that answers your question. For single port internal versus external. Korku, that's a tough question. Asking about PIM on rooftops. Your questions about PIM cancellation devices. Yes, there are companies that do interference cancellation, I'm going to call them. I am not an expert on interference canceling. There are companies out there. The name I know is ISCO. That's one of them. The carriers that are on the phone probably have way more expertise with those products than I do. And I'm speaking, to the service providers that are on the call. Yeah, they have them. This is not an interference canceller. This is a identification tool to show you what the system sees. So, but yeah, there are pluses, minuses. I'm not the guy to talk about it. We're not the company to talk about it because we don't do that, right?
Real quickly, Dan, a couple of people have asked how to sign up for the next sessions. The next session is April 6th on mid-band intercell interference. Invitations are going out today for that one, might even be in some inboxes already. And I did put the registration link in the chat. You can register right now if you want.
Okay. And I'm sorry for jumping around again. I know we're recording this. I want to get to Aziz's before we get off. How do I sign up for this? Thank you, Mommy. This only works on 800, not older 700 series. Bill, I don't know what a 700 series are. Eduardo, obviously, if we know what that is, I only know. Yeah, go ahead.
Yeah, we also have our RFoCPRI capabilities on the 700 series of the 780 platform.
Yeah.
So yeah, it's also possible to do it. Is not going to be probably as clean and easy, but that we have here in the OneAdvisor. But yeah, it's also possible.
It's funny, I can't remember my my own products. So thanks, Eduardo. That'd be the 785, by the way. If you had said that, I would have got it. So thanks, Bill. So there was a question on tapping. Eduardo, do we have a slide on? Do we have any better slides on tapping in the last couple minutes?
We do. We can send that via email. Yes.
Yeah.
Certainly.
Okay. So how you tap, I'll walk you through a little bit of it, just so we can see it, right? So you can see from a power level. This is how you. This is the fiber tapping screen. We don't really show a lot. You disconnect the RRH or RRU if you're in an Ericsson world from your baseband unit or DUS, whatever you want to call it. In our tap, you would plug that into port A, which we like to call it A because it's for the antenna. And then you take a jumper fiber from port B, which goes to the baseband unit, hence port B. And that will allow the radio and the baseband unit to talk again without seeing anything. Loses a little bit of power because we steal 3 dB of light out of it. And then next to that tap, which we can put in a picture, there is a monitor port. There's 2 monitor ports. Actually, one to monitor what's coming out of the baseband unit. We don't care about that because we're not in manufacturing and we're not here to fix radios. And then there's one to tap everything coming out of the RRH or RRU. And that's the one we plug into. Again, if it's our tap, it's the top one. It's always the top one. That goes into the ONA SFP, which in this case, it's just I'm using a Finisar 10 gig SFP, nothing special about this SFP. And I hard coded my rate just because I know the radio I'm on, but most people hit the auto button and it will rate select itself, right? I just happen to know the radio I'm on right here. And that's it. So the tapping is fairly straightforward, easier when you see it. We have some different Prezos that have it in it, but in the case of time, I can't pull it up right now. So hopefully that helps with that. And a couple of last questions. Sam, I will type my email in there. It will be on the presentation on page 1 with Eduardo's, just so you know, but I'll get that typed in a minute. We are recording this video, yes. Gloria takes care of all that. I believe you all get a link at the end of this. Do you have some information on external interference for TDD 5G or gated sweep? That is a topic we're going to do in one of our future sessions. So I believe that's Fidel. Thank you. Yeah, we absolutely. I think that might be our next session, Eduardo. Is that true?
It's going to be one after next.
One after next. So in a couple of weeks, yes, we specifically have use cases around T-Mobile's N41, CBRS, and C-band. I don't need to spell out the bands. Anything above 2.5, above Wi-Fi, will be TDD, and yes, we are going to have a big session on that because we're finding a lot. And Nathan will get you out our tap specs. Absolutely, that's easy to do. So I'm going to put my email. I think you guys all see the answers to these. My email is here. I'm giving you my old one because nobody can spell my name. So you should all have my email now. And we're happy to help. I back up Eduardo, and when you get this presentation, you'll be able to chat with both of us.
Very good. Thank you, Dan.
Absolutely. Unless you're Scott. Scott can't call me. He's the only one because he heckled me and I told him no more heckling. But Jim, you can call me anytime. So. All right, Eduardo, I'll hand it back to you.
No, well, back to everybody, just to thank you all for attending and participating. And again, if you have anything that comes up and you might have questions, feel free to send those over. And Gloria, we're gonna be sending the presentation material, and as Gloria said, we have the invite going out for the next session.
Correct. And so I want to thank everybody. This session was recorded. It takes a couple of days to get it processed and then added to our website. I will get the slides from Eduardo to PDF and have sent out to you. And if you have any further questions, I did put in the chat Dan's email address, his official one, and he gave you the easy one because his name has
Sucks.
lots of vowels, lots of consonants in it. And Eduardo's is in there as well. So we want to thank you for your time today. It sounds like this session was timely and very valuable. We look forward to seeing you on the webinar that is coming up on April 6th on mid-band intercell interference. Again, that link is in the chat. You can register for it right now. Go ahead and do that, even if you're not sure of your schedule, because then at least you'll get the information as we move it forward, even if you're not able to attend. And we thank you for your time and hope you all have a great afternoon.